This is Algebra 1, Unit 2, Lesson 11, more work with compound inequalities. Okay, so let's take a look at some compound inequalities and graphing them and being able to describe the solution sets. We did a little of this the day before. So let's look at the compound inequalities, the number of lines for C and D, and write the inequalities as a single statement. All right, so let's graph this. We have x is less than 1. All right, so at 1 is going to be our critical point. Is it open or closed? Well, it's not equal to, so it should be an open circle. And which way does it point? Well, less than 1 would be in that direction. Or x is greater than or equal to 4. All right, so my critical point is going to be at 4. And it's filled in because it does equal 4. And where is x greater than 4 is going to be to the right. So this is an or. They're going in two different directions. So remember, with an or statement, it only has to be true for one of the statements. So it could be this one or this one. Let's look at letter B. X is greater than 7. All right, 7 is my critical point. It is going to be open circle because it does not equal 7. Greater than 7 will be to the right. X is less than negative 2. 1, 2, right here. Also going to be an open circle. And less than is going to be to the left. So any value that falls within here or here will make this inequality a true statement. Okay, now, where it gets a little complicated is x is greater than negative 3 and x is less than 5. Remember, with an and statement, it has to be true for both statements at the same time. All right, so let's see what we have when we do this. X is greater than negative 3. 1, 2, 3, negative 3. Open circle because it doesn't include it. And it should be pointing to the right, like this. X is less than 5 is also an open circle because it doesn't include it. But less than 5 will go this way. So we are looking at the overlap. Now, we can describe this as a single inequality. When does this inequality, or the solution to this inequality start? It starts at negative 3. Whoops, let me put it down here. When does this inequality stop? It stops at 5. All right, so the x values fall between negative 3 and 5, but are they included? No. So x would have to be less than 5, but greater than negative 3. So that describes as a single inequality an and statement because we're looking at a starting and a stopping point and everything between it. Okay, let's try this one. X is less than or equal to 9. All right, so that means 9 is our critical point. It's going to be filled in. And less than goes like this. And then x is greater than or equal to 0. 0 is my critical point. It is equal to, so it includes that. And would go like this. So this is x is less than or equal to 9 and greater than or equal to 0 at the same time. So if I write this, it starts at 0, it stops at 9. These points are included, so x is going to be less than or equal to 9, but greater than or equal to 0. So we can do it all in one thing because the x is describing both of these at the same time. So the overlap one is the only one that you can do a double inequality for. These have to be separate inequalities because they're going in opposite directions. Okay, so now that we know that a single inequality can be written for two separate inequalities, let's see if we can transfer the other way. We have negative 4 is less than or equal to x is less than 6. Okay, if we read this from the x, what two inequalities does this give me? Well, if I look at just one half of this, if I just look at this half right here, what is x, how does x relate to negative 4? It is greater than or equal to negative 4, and it is also less than 6. So my two inequalities, this is going to be x is greater than or equal to negative 4, and x is less than 6. So all we have to do is graph each one of these. Greater than or equal to negative 4 is a solid circle because it is included. And then 6 is an open circle because it's not included. And remember, this is an overlap, so this is when x is between negative 4 and 6, not including negative 4, but are including 6. So your overlap is going to be like this. Okay, what are my two inequalities for this one? Well, reading from the x, x is greater than or equal to negative 5, and x is also less than or equal to 9. All right, so this is going to start at negative 5, and it is included because it's equal to. And then it's going to stop at 9, also included because it's equal to. And the values of x have to fall between negative 5 and 9 inclusive. So it's going to look like that. So these, you should be able to go between this inequality and what actually the two inequalities you're talking about when you do that. All right, so let's see if we can figure out what kind of inequality this is going to be. All right, looking at this inequality down here, is this an and or is it an or? Well, it's going to be an or because these go in two different directions. They don't overlap. So we know this is going to be an or. All right, now if I describe this half of the inequality right here, where does this inequality begin working? Well, it starts back here at -1. Is -1 included? No. All right, so we know it's going to be -1. All right, what are the x values that relate to -1? Well, the values over here have to be less than -1, but not including them. So this is going to be x is less than -1. Now this one is an or. The other half of the or is going to be starting at 5. Is 5 included? Yes, it is. And all the values of x related to 5 are greater than. So x is going to be greater than or equal to 5. It's equal to because it's filled in. So x is less than -1 or x is greater than or equal to 5. So that describes both of the inequalities using the or statement because it has a gap in the middle. It doesn't overlap. Okay, how about this compound inequality? Does this one overlap? Yes, it does. All right, so what are my starting and stopping points? All right, my starting point here, -6, -7, -8, and 2 are my stopping points. All right, are -8 and 2 included? No, they're not, because they're both open circles, but it goes up to -8 but doesn't include it, and goes up to 2 and doesn't include it. So x is going to be less than 2, but greater than -8. All right, so now let's solve some compound inequalities and figure out what our solution sets are going to be. All right, so we have this compound inequality, 6x plus 1 is greater than or equal to 4, and -2x plus 8 is greater than -12. All right, now we can plug in like we did before and figure out both inequalities and see if it's true. But let's use our graph and do it. Let's solve each of these inequalities. 6x plus 1 is greater than or equal to 4. All right, so I'm going to solve this for x, subtract the 1. 6x is greater than or equal to 3, and then divide by 6. Now be very careful here. 3 divided by 6 is x is greater than or equal to 1/2. All right, now this is going to be and. I want -2x plus 8 is greater than -12. All right, I want to subtract the 8. -2x is greater than -20. And then I want to divide by -2, which should send off alarm bells in your head, because what happens when you divide by a negative? The inequality will flip the opposite way. All right, so -20 divided by -2 is 10. All right, so I have x is greater than or equal to 1/2, which would be 1/2 would be right here. 1/2 is included, and greater than would go this way. And then x is less than 10 is not included. It's open circle, and it should be pointing this way. So it's going to overlap going like this. So if I write my solution to this on the number line, it's going to be -1/2, and 10 is my solution. X falls between them, does not include 10, but does include -1/2. So there's my inequality. X has to fall between -1/2 and 10. Okay, so now if I want to determine whether the values of x fall in the solution set of this compound inequality, I could actually just plug these in and see if it would be true. Which one should be true? Well, let's look at x equals 5. Does that fall in the area? So yes, this is a solution. All right, if I were to plug in 5 here, this would be 6 times 5 plus 1 is 30 is greater than or equal to 4. And -2 times 5 is -10, plus 8 is 2 is greater than -12. So both of them would work. So that one is yes. All right, how about x equals -3? Does that fall in the solution set? No, -3 is right here. That's not within this area right here. So this one is actually going to be no. So if I plug -3 in here, neither of these inequalities would work. All right, how about 10? Is 10 included? Be careful on this one. No, it's not, because what happens at 10 for this value? 10 is not included, so this one is actually also going to be no. So having the graph is very handy to help you figure out whether it's a solution or not. All right, let's do one more. We have the compound inequality shown here. We have 1/2 times x plus 4 is less than 5, or -2 times x minus 4 is less than or equal to 14. All right, we're going to do the same thing we just did, but let's solve these. 1/2 times x plus 4 is less than 5. All right, so if I solve that, I get half x plus 2 is less than 5. I'm going to multiply both sides by 2 to get rid of my fraction. And I get x plus 4 is less than 10. And then I subtract the 4. So x is less than 6. Okay. And the other one, we have or. That's my other one. Negative 2 times x minus 4 is less than or equal to 14. So that gives me negative 2x plus 8. Watch your signs when you distribute. It's less than or equal to 14. Subtract the 8. Negative 2x is less than or equal to 6. Divide by negative 2. Alarm bells should be going off in your head. Flip your inequality because we divided by a negative. X is greater than or equal to negative 3. All right, so let's look what we have here. X is less than 6. 6 is going to be an open circle, and it's going to go like this. X is greater than or equal to negative 3 is going to be a closed circle. 1, 2, 3, right there. And it's going to go like this. Okay, so what do we notice about the values of x that work? Well, let's see, x equals negative 6. Does that work? Yep, that one's yes, because it works for this one. Because remember, for an or statement, it only has to work for one or both. All right, how about x equals 0? It would be, works for this one, so yeah, that works. Okay, how about x equals 8? Yep, that works too. All right, so what do you notice? Is there any value of x that does not work here? Well, this one is covered by this inequality. This is covered by both of them, and this part is covered by the other one. So what does that tell me? Well, if x is less than 6 or x is greater than or equal to negative 3, that means your solution is going to be all real numbers work. There's all the values of x will work because we've covered every possibility. So all real numbers work, and that is your solution. Okay, so that is about compound inequalities. Your homework will be the worksheet that goes with this.